A, B, C are 3 points given by those position vectors, A, B, and C, with respect to origin O. So it says in A, find A, B in terms of I and J. Now, diagram will always be helpful, okay? And notice here they've given us the position vectors. So that's like the coordinates, if you like, how to get to there from like the origin in terms of I and J. Now, they're asking us for the vector A, B. So remember, if relative to the origin, okay, there would be the origin, and that will take you to vector A. This will take you to vector B. They're asking for the vector AB, yeah? That's what they want in part A. Now remember, to get from A to B, okay, we would think about how to get from here to here. It's the equivalent of going from A to O and then O to B. And remember, we know O to A is little a, given there, and we know O to B is little b. So to get A to B, quite simply, we're going to go backwards here, so that'll be minus A, and then we're going to go forwards here, that'll be positive B. So you can write minus A plus positive B, or you can write that as B take away A. Okay, that's what AB will be. Now, of course, we know little b is given in terms of I and j, so we've got 14I minus 2j for b, and then take away then little a, and little a is 2I, so we're going to put it in a bracket because we're going to take away it all, take away 2I plus 3j, so then I get 14I minus 2j, the minus applies, so minus 2I, and then the minus applies again, minus 3j, so I get 12I minus 5j, okay? Then it says in part B, find the length of the line AB, okay? So we know from part A that the vector AB is 12I minus 5j. Now, we don't have to worry too much about getting sort of accurate measurement here in terms of scale, but what we need to appreciate is here that this literally means going 12 across, okay, in terms of its direction, and then 5 then in the sort of negative j direction there, okay, right? So that's the sort of direction we're heading in. We're going across 12 and then down 5, so to speak. Think of it that way. So overall then, going from A to B, we'd have then that distance there from A to B. So if we go in 12 across and then sort of 5, negative 5, so 5 down, we can just put 5 there because we're talking here about size. Then we can work out what AB is, quite simply, of course, using Pythagoras. So the size of AB will be Pythagoras. So if you remember Pythagoras, we square the two smaller sides, so A squared and B squared, yeah, so 12 squared, 5 squared, you add them, and whatever that result is, then you square root it, okay? So you can do all that in one go, and we get the length then to be 13, okay? Part C then, it says find the position vector of M. So position vector, remember now, is like coordinates. How do you get there from the origin? And M is the midpoint of BC. So, I'm going to find this helpful to draw a little sketch, okay? So, there's B, there's C, and there's my origin. Okay, now I know little b, because they give it in the question, and little c they give in the question as well. But M is kind of like exactly, it says halfway between B and C, okay? So roughly about there, that's where M is. So we want to know what sort of coordinate, if you like, or that position vector is there. In other words, how do you get from O to M? That's sort of what we want, okay? We want OM. Now, if you think about it, O to M, you can get there by going O to B plus then B to M. Yeah, you can go that way. You can go along that path, OB, BM. And of course then, BM is like going along the same path as BC. So if we can work out BC, we could then just halve it, couldn't we, to get BM. Alright, so let's do BC to start with. I think that would make sense, BC. So remember now, BC, if you think about back to the start, AB was B minus A, so kind of like ends in B, starts with A, so you kind of reverse here, starts with B, ends in A, so B minus A. Similarly then, BC ends in C, so little c, take away then little b, okay? You can work it out you get to that answer. We know then little c in the question given to us at the top is minus 8 plus 3j, and then take away then little b, which is, so put in a bracket, 14i minus 2j. So I get minus 8i, and then minus 14i is minus 22i, and then 3j, and then don't be careful here, minus, okay? The minus and the minus, let's write that out in full. Minus makes a plus 2j. So I get minus 22i plus 5j. So that's what BC is, okay? But then if we think about it then, to get OM, as I discussed earlier, to go from O to M, we need to go O to B, okay, O to B, plus then BM, and O to B is just little b, isn't it? And then BM is like half of BC, so half of this, okay? Half of, well, let's write half of BC to start with, and I can write them in. So I'm going to put B here, which in the question was 14i minus 2j, and then half of BC, which is minus 22i plus 5j. So we work that out to be 14i minus 2j minus 11i plus 5 over 2j. So that simplifies to be then 3i, and then that would be minus, plus 1/2 j. Okay, so that will be the position vector. So O of M. In other words, OM is 3i plus half j.